Good morning and welcome to today's class. Today's class is a continuation of our previous classes on Surds. In today's class, we shall be taking the second objective of this course. Remember, at the previous classes, all we're trying to do is to differentiate between rational and irrational numbers. And in our previous classes, I also introduced you to basic surds and single surds. We looked at both of them, how to convert from basic surds to single surds and how to convert from single surds to basic surds. If you didn't join us at the last class, you can follow the link just above this video to go back and study on single surds and basic surds and how to convert from one form to the other, because that will help you in this next objective. In today's class, we shall be applying the rules of addition and subtraction of surds in solving surds problems. This is a continuation of what we did at the last class. Without the knowledge of last class, it will be very difficult for you to know how to apply the rules of addition in surds, because we shall be making use of basic surds, single surds. You hear me saying these words: single surds, basic surds, and how to convert from one form to the other. So last class introduces us into basic surds and single surds and how to convert from one form to another, where I equally left that class with an assignment. So in today's class, before we look at the addition and subtraction of surds, we shall look at the solution of the assignment I gave you at the last class. That of assignment 1, you should be able to do it because I have already solved the solution to the first assignment I gave you. So I will be giving you answers to the assignment 2, where we're asked to express each of the following as a single surds. Now, they were all given in their basic forms. Okay, it is now left for us to convert them from the basic surd forms to the single surd form, which will equally help us in today's class, which has to do with addition and subtraction. So I will not be taking it step by step. I will be skipping some steps just to give you the answers. You can also use this trick in objectives, where you have them in your objectives. You can apply them in solving it. Now I'm asked to express 2 root 2 in its basic single surd form. All I need to do is to square 2 and multiply it with the irrational part. This is the rational part and this is the irrational part. So square that of the rational part and multiply it with the digits under the square root sign and put all of them under the square root sign. That gives you the equivalence in its single surd form. So 2 squared is going to be 4, and 4 times 2 is 8. So 2 root 2 is equivalent to root 8, but you can still go through the method I gave you at the previous class and you arrive at the same answer. B, 3 root 5. Square 3. The square of 3 is 9. 9 times 5 is said to be 45. So this is said to be equivalent to root 45. C, 4 root 2. The square of 4 is 16. 16 times 2 is 32. So this is equivalent to root 32. And you do same to this. Square 16. If we have to multiply 16 by itself, 6 times 6 is 36. You write down 6, carry 3. 6 times 1 is 6, plus 3 is 9. 1 times 6 is 6. 1 times 1 is 1. So this gives you 256. So 16 squared is 256. 256 times 3. This is 3 times 6 is 18, carry 1. This is 15 plus 1, 16, carry 1. This is 6 plus 1, 7. So this is equivalent to root 768. E, 8 root 3. Square of 8 is 64. 64 times 3. This is 12. carry 1. This is 18 plus 119, which is equivalent to root 192. All you have to do is to square the rational part and multiply it with the digits in the irrational part. And finally, f 2 root 5 is said to be square of 2 is 4. 4 times 5 is 20, and this gives you root 20. So these are the shorter ways you can use in conversion from irrational from basic sort form to single sort form. Now let's go over to today's class. Today's class we shall be looking at the addition and subtractions of surds. Having learned how to convert from single sort forms to its basic sort forms, as well as from its basic sort forms to its single sort forms, this will enable us in the addition and subtraction of surds. Now, when you are solving any problem that has to do with surds, where you're asked to either add or subtract, you follow the normal algebraic processes. When you are to add, you add like terms. Okay, those that are like terms, you add them together when you're asked to simplify. And when there's no like term, then you cannot add or subtract them. Rather, you just write a plus b. But if you have 2a plus 2b, definitely you have to sum them up together because they are like terms. So also in surds, we have what we call the like terms and that which is not like. Now, how do you know if they are like terms? Okay, let's look at this. That only similar surds can be added or subtracted. Sometimes one may need to simplify such surds before adding or subtracting them. Yes. So then you may not know if they are similar or not unless you reduce them from their single sort forms to their basic sort form. So when you have a problem that has to do with sort, the first step to take is to first of all reduce or simplify all those that are in their single sort forms to their basic sort forms. Once that is done, you'll be able to know which are similar sorts and which are not. Remember at the last class, in one of our classes, when we're discussing similar sorts, we say two sorts are said to be similar if their irrational parts are the same. For example, you have 3 root 2 plus 4 root 2. These are said to be similar sorts because their irrational parts are the same. And what are the irrational parts? Root 2 and root 2. 4 and 3 are said to be rational numbers. Okay, so we are not considering the rational numbers, but rather the irrational parts. Once the irrational parts are the same, then you are bound to add them together, or you can subtract one from the other. But once they are not the same, or once they are not similar, you cannot add them together. So for this example, they are both in their basic sort forms, so it will be very simple for me to add them. Also, you can refer to them as, let's take root 2 to be x. The same thing as you saying 3x plus 4x. Or take them to be apples. 3 apples plus 4 apples. They are similar, so you can add them together. But if one happens to be in maybe x and y, you can't add them together because they are not what? Similar. So in this case, this becomes 3 root 2 plus 4 root 2 can be said to be equal to 7 root 2. For 3 plus 2 is 3 plus 4 is 7. B, we have 6 root 3 minus 8 root 3. Remember what I said. First of all, you should ensure that they are all in their basic sort forms before you can simplify. Even though they are not in their basic sort forms, at least they should be similar. That is the aim. If they are not similar, then you can reduce them to their basic sort forms and you may find them to be similar. Alright, so we have 6 root 3 minus 8 root 3. And 6 minus 8, we know is going to give us a negative number. So this is equal to negative 2 root 3. When you use your number line, for 6 is less than 8. So it's going to give you a negative value. C, we have 8 root 27 plus root 75. Now, they are not similar. If you look at their irrational parts, this is root 27 and this is root 75. They are not similar. but we can't tell whether they are similar or not unless we reduce them to their basic sort forms. And once that is done, then we can tell if they are similar or not. So this is how to reduce. I'm going to take them one at a time. So 8 root 7 can be expressed as 8 times, remember, root 27 can be expressed as a product of two factors where one is a perfect square. And just like I said in our previous classes, look for two factors that you can multiply to get 27 where one is a prime factor, and thereby start by dividing 27 by all the prime factors. 2 is not a multiple of 27, so 2 cannot go. So we'll rather begin with 3. For when you divide 27 by 3, it gives you 9. That means 3 times 9 will give you 27, and 9 is a perfect square. So that can serve as root 3 times 9 plus, also do same to root 72. Root 72 can also be expressed as 3 times 25. Now, in most cases, when you get the prime factor of the first digit, try and see if it is also a prime factor of the second digit, so that gives you similar sorts. And that's what I did. Having discovered that 3 times 9 is 27, I now ask myself, what will I multiply by 3 to give me 75? And he said it's 25, of which 25 is also a perfect square. So this can be simplified to be 8 times root 3 times root 9. Remember what we did? I'm only trying to simplify them. Plus, this becomes root 3 times root 25. So remember, this is still in bracket so as not to confuse yourself. This can be said to be 8 times root 3 times root 9 is 3 plus root 3 times 5. That's this root of 25. So you can simplify this, multiply. This is now becomes 24. I'm multiplying the rational parts together, which are 3 and 8. So when you multiply 3 times 8 together, it gives you 24 root 3 plus 5 root 3. Now, when you simplify this, you will discover that from what we got, or from the question, which looks as if they are not similar, but because I have been able to simplify it, okay, to its basic sort form, they are now similar. Okay, so you can now add them together because similar sorts can be added or subtracted. Okay, so this becomes 24 root 3 plus 5 root 3 will now give us 29 root 3 as our answer. So whenever you're asked to simplify problems that have to do with sorts, the steps you have to take is to, first of all, try to reduce them to their basic sort forms if they are not, and then you can collect like terms. D, we have root 32 plus root 72 minus root 128. So we shall be simplifying them to their basic sort forms and thereafter collect like terms, and that gives us our answer. So root 32 can be divided into root 2 times 16 plus 72 can be said to be root 2 times 36 minus, this can be said to be root 2 times 64. Okay, now you can simplify them further. This is equal to root 2 times root 16 plus, do same to the second, root 2 times root 36 minus root 2 times root 64. So when you simplify, this gives us root 2 times 4 plus root 2 times 6 minus root 2 times 8. When you collect like terms or simplify before you do that, this gives us 4 root 2 plus 6 root 2 minus 8 root 2. So they are all now in their basic sort forms and they are similar. So we can add and subtract one from the other. So 4 root 2 plus 6 root 2 can be said to be 10 root 2, then minus 8 root 2. And when you subtract this, it gives us 2 root 2 as our answer. So you can leave it in their basic sort forms. Also note, when you arrive at your answer, you should ensure that it is always in its basic sort form, unless otherwise stated. Then you can leave it in its single sort form. That brings us to the end of today's class. In today's class, we have been able to look at how to apply addition and subtraction of sorts in solving problems. Don't forget to like our videos as you watch, while you are encouraged to share with your friends and also subscribe if you have not done that. We also have the comment section where you can use to interact with us on how you feel about our video. In our next class, I shall be solving more exercises on addition and subtraction of sorts in solving problems. See you in our next class, and watch out for the assignment I will give in the next class. Have a nice day.